Circuit analysis, electrical circuit analysis subject, delta or connections, balance load formula. My engineer welcomes you all. Important formulae for balanced three-phase system delta connections. The analysis of three-phase balanced system is presented in this section. It is no way different from the analysis of AC system in general. The relations of voltages, currents, and powers in delta connected and star connected systems has already been discussed in previous class notes at Math Engineering Link. We can make use of these relations and expressions while solving the circuits. In this video, we see balanced three-phase system delta load. Figure shows the three-phase, three-wire balanced system supplying power to a balanced three-phase delta load. The phase sequence is RYB. We are required to find out the currents in all branches and lines. Figure RYB is the phases, VRY, VB or VYB is the with the angle, that is phase voltages. IR, IY and IB are the phase currents. I1, I2 and I3 are the line currents. Let us assume the line voltages. The phase sequence is RYB. Assume the line voltages VRY is V angle of 0 degree as the reference phase. Then the three source voltages are given by VRY is V angle of 0 degree in volts. VYB is V angle of minus 120 degree in volts. VBR is V minus 240 degree in volts. That is important formula for phase voltage calculation is delta connection balance load. These voltages are represented by phases in figure B. Since the load is delta connected, the line voltage of the source is equal to the phase voltage of the load. The current in phase or IR will lead begin ahead of the phase voltage VRY by an angle phi as dictated by the nature of the load impedance. The angle of lag of IY with respect to VYB as well as the angle of lag of IB with respect to VBR will be phi as the load is balanced. All these quantities are represented in figure B. Kindly noted IR will lag or lead begin ahead of the phase voltage VR by angle phi is dictated by the nature of the load impedance. If the load impedance is AZ angle of phi, the current flowing in the three load impedance or then IR as VRY angle of 0 degree divided by AZ angle of phi is equal to V divided by AZ angle of minus phi. Then find out I1 and IB formally. IY is VYB angle of minus 120 degree divided by AZ angle of phi is equal to V divided by AZ angle of minus 120 degree minus phi. Then IB formula is VBR angle of minus 240 divided by AZ angle of phi is equal to V divided by AZ angle of minus 240 minus phi. The line currents are root 3 times the phase currents and 30 degree behind the respective phase currents. Previous classes I already explained that points. The line currents are root 3 times the phase currents and 30 degree behind the respective phase currents. That is important for line current calculations. The line current in the line A1 is given by I1 as root 3 modulus of V divided by AZ angle of minus phi minus 30 degree. Or I1 as IR minus IB phase difference. Similarly, the current in line 2 of an I2 is root 3 modulus of V divided by AZ angle of minus 120 minus phi minus 30 degree. or IY minus IR. Phase difference, that is I2 is root 3 V modulus of V divided by Z angle of minus 5 minus 150. And then calculated I3. I3 is root 3 modulus of V divided by Z angle of minus 240 minus 5 minus 30. Or I3 is IB minus IY phase difference. I3 is root 3 modulus of V divided by Z angle of minus 270 minus 5. That is important formula for I1, I2, I3 line currents calculations. To draw all these quantities vectorially, VRY is equal to V angle of 0 degree is taken as the reference vector. That is important point for calculations. VRY is taken reference vector. That is balance delta connections calculations, line current calculations and phase current calculations and phase voltages calculations. Man engineering, thank you.